Hey, what's up? As I mentioned before, I wanted to create a UNROM Famicom cartridge from scratch for my game. The goal is to make a semi-professional looking cartridge PCB at home with my limited electronic skills, so that I could actually have a physical medium that I could give to someone. So in this video I'm going to make this cartridge. I already did a test run before by trying to produce a very simplistic Atari 2600 cartridge, and the results were pretty good, if I dare to say so. So I've decided to move a bit further. First things first, I need to draw the cartridge schematic. As in my previous cartridge making attempt, I am going to draw the schematic and design the PCB with KiCad. So to draw the schematic, I need symbols for all the components I'm going to use. Unfortunately, there is no ready symbol for the Famicom cartridge port, so I had to create it from scratch and specify all 60 pins. Okay, let's add the port to the schematic. Now how about the symbol for the EEPROM I bought? By the way, I've decided to make my life a bit easier and I bought an electrically erasable ROM, since erasing with UV light is such a hassle. I need to wait for 20 minutes or so every time I want to erase the chip. Surprise, surprise, the symbol for this EEPROM wasn't available. I guess these parallel 8-bit EEPROMs are ancient technology by now, and probably nobody's using them anymore, except such weirdos like me. The serial EEPROMs are way more common nowadays. There was no symbol for the static RAM chip as well. I kinda tried too hard with this one, since I later found out that this Sony static RAM chip I bought was actually used in the American Contra cartridge. I kinda wasted 10 euros for this chip, because at that time I had no idea that the hint of what kind of RAM I need was on the bootleg cartridge all along. So that's the 6264. Later I bought some cheaper Taiwanese SRAMs. Luckily there were symbols ready for the logic chips, so I could place them right away. The OR gates are displayed like this group of separate elements, but in reality it's a single IC. So as with the cartridge connector, I had to find datasheets for the ICs and create the symbols manually. Finally, I had all the components in my schematic and it was time to connect them together. I'm not adding any capacitors, since I know that they aren't that necessary. Perhaps I will add them in later iterations of this cartridge. Even though I tried to use buses, my schematic ended up looking quite messy. Well, I'm not really good at this yet. At the very end I decided to drop in the symbol for the mirroring jumpers. After I connected everything, I could finally start designing the PCB. But first I needed to create footprints for my custom components. Luckily for the ICs, KiCad suggested me to use already made dip socket footprints. And that's great. I was going to solder sockets in any case. But I still had to make the cartridge connector from scratch. For some reason I used a bootleg cartridge as a reference, but in the end the connector ended up being really good. After I placed the contact plates on the one side, I started placing them on the back side of the PCB. And here I made a rookie mistake. You will find out what it was later. So, as soon as I was finished with the cartridge connector, I switched to the PCB design window. Here you've got a jumble of connections and you have to untangle them and lay out the tracks for each of them, as they would be on the finished board. Here I noticed that something is weird. The one side of the PCB was kinda okay, but the back side for some reason was impossible to wire. Of course, I could have simply looked at the original cartridge's wiring, but I didn't want to copy the Nintendo's design. I said to myself, I'm gonna do it my way. Also, I haven't slept the night before, so I guess that explains why I did this insane thing. I kept going and wiring the PCB no matter what, and I finally did it. But my result was the embodiment of insanity. It had millions of wires and these insane twists and turns of leads packed tightly together. I looked at the bootleg PCB that I had on the table. Well, it looked equally insane. I thought maybe that's the way to go. Although the pirates had an excuse, their cartridge was a multicart and had these epoxy blobs. The next day, when I woke up, I sensed that I did something wrong. I thought maybe I should give the PCB to the free routing application to wire it for me. Maybe it will do a better job. But for some reason I decided to try one more time. And during this attempt I tried to follow the original Famicom cartridge's wiring. And by doing that I quickly discovered that my cartridge connector's backpins are flipped. Dang it! So that's why it was so hard to lay the tracks. When I fixed my mistake, I saw how everything became simple and elegant. No more tightly packed tracks and hundreds of wires. I think this time I added way less wires than there were on the original Famicom cartridge. Probably I had it easier because of my decision to put the ICs in the front of the PCB and not backwards like the Japanese did. I think it made the wiring a lot more simplistic. So here's how my final product looks. I was so proud that I even put my channel's URL on it. Now let's move to the next step. Let's print the PCB layout and transfer it on the copper plates. Just look at the difference of what I was thinking was a normal PCB layout versus the actual PCB layout. Still, if I would compare this layout with the one that I did for that R2600, the correct one still would look kinda intimidating. I haven't tried to etch traces that thin before. The TAR cartridge I think had like 0.5mm traces, so I had no idea of what the result would be, and to be frank, I didn't even had high hopes. As previously, I've printed my layouts on pieces of an old magazine paper that I stick to the page. Also, the front side of the PCB is mirrored. Notice I added thick crosses to help adjust both PCB sides. Then, as usual, I marked and cut out a piece of copper-clad laminate that's exactly the size of my prints. I filed the edges, sanded the copper a bit, and cleaned it with some isopropyl alcohol. Now I was ready to put the pieces of magazine paper on the plate. Same as before, I used my 2-chair and a lamp contraption to align both sides. I put some super glue on the first piece of paper so it would stick to the plate. Then I started aligning the second piece, so it would match crosses that I have printed. One thing I need to do differently next time is to move those crosses further away from the drawing, because it was very hard to align them when the paper bends on the edges of the copper plate. When I was sure that both sides were aligned, I put some duct tape to keep them in one place. Then it was time for ironing. Nothing special there. I just put my board in between cleaning rag and ironed it for 10 minutes or so on a maximum heat. After the plate cooled off, it was time for a little soaking in a sink, so I could remove the paper. Let's look closer at the results. It's not that bad. Well, there are some imperfections on one side. I'm guessing that's because I tried to touch that side with the iron directly without the rag. But that's not a big deal. I can fill in missing parts with a marker. So let's do that. Okay, it's time for etching. I'm making a new solution of sodium persulfate because I haven't tried to etch with an old solution yet. So I don't want to risk it and ruin this PCB. So that means I will have more jars with a blue liquid in my balcony. One thing I've noticed is that if the liquid's temperature is lower than 40 degrees of Celsius, it won't do anything. But once the temperature rises, you can instantly see the copper coming off the laminate. So, let's look at what we got here. I'd say I'm really happy with the results. I did not expect for them to be that good. Now the part I hate the most, the drilling. I bought some cheap 0.5mm drill bits from a local hardware store, and I kinda regret I did that, because they were a complete trash. And while drilling this cartridge, I broke all 4 of them. Another thing to remember, you must drill from one side only. You should not drill one hole from one side and then flip the board and drill another hole. This leads to a major problem I had with this cartridge. More about that later. Also, it is very important to keep the drill bit straight, because a minor lean to a side can lead to a misplaced hole on the other side of your PCB, no matter how good you aligned both prints. So yeah, visually it kinda looks okay, the holes are where they're supposed to be, but in reality the things are not that good. Now let's clean the PCB with some acetone. I regret I haven't used it in my previous PCB etching attempt, because it cleans the toner so effortlessly. Since I'm using sockets, I had to make the holes a little bit bigger with a small file. Then I cut off the unnecessary parts of the laminate, and the cartridge PCB finally took its final shape. So it was time to give the copper some protection. Like in my previous attempt, I'm using solder for it. I covered the PCB with some liquid flux and then applied the solder. The results weren't that great and not very pretty to look at, but it doesn't matter much. What matters is to make the contact plates as even as possible, so they need some extra scraping with a desoldering blade. Then, one by one, I started soldering in the sockets for the ICs, and as I went, I tested every trace. I used resistor legs to fill in the wire holes, just like the last time. At that point, I found out that some traces actually had some small fractures and weren't conducting the current very well, so I had to fix them. Before I put in the chips, I did a small test to be sure every chip could be powered by the Famicom. Thanks to that, I found that one chip had unsoldered 5-volt pin. After this test, I could start putting in the ICs and finally test the cartridge. But first I needed to write some ROM image to my EEPROM. As usual, I've used my cheap Chinese XGECO Pro programmer. To burn the NES file, first you have to remove the header that is used only by the emulators. You can open the file with some hex editor and delete 16 bytes from the beginning of the file. Or you can use the so-called advanced NES ROM Utility and it can do it for you. The final goal is to have a file of 131,072 bytes. This image can be written to the EEPROM chip. So let's do it. Now I can put the EEPROM in and finally test the cartridge. And guess what? Despite all the testing I did, it didn't work. But why? So my first guess was perhaps I'm using the EEPROM the wrong way, because I haven't used those ICs before. So I tried to put it in to my old DIY cartridge and test it. For some reason I came to a conclusion that I need to give 5 volts to the PGM pin, since in the datasheet it is marked as inverted. So if it has nothing connected to it, the chip probably is thinking the programming mode is active. Also, I thought it's important to cut the power from the VPP pin,
But later on I found out that actually the CPU address pin 8 was not connected, and that was the main reason why the program was not running on the console. Unfortunately, this did not solve all my problems. My game still showed no signs of life, but the Contra ROM actually showed a gray screen. So that's something. Surprisingly, there was one ROM that did something more. It was the same Famicom cartridge I opened in my last video and used it as a reference. Sadly, it was only its title screen that was working, and it was all wrong. After an attempt to start the game, it just stopped. So at that point I acted foolishly again and wasted time looking at that game's assembly code. You would say, well, you know assembly, how hard would it be to figure it out? But there's nothing more worse than the someone else code that has no comments, no subroutine names, and no variable names. Later I even tried to solder caps to the chip. Though they are a good thing to have, they weren't the solution to this problem.
The next day I made a progress towards the right direction. I took the code from my first NES episode and adapted it for the UNROM mapper. So the code itself was pretty short, less than 3 kilobytes, and it worked instantly. But surprisingly, I could not see any background tiles, only the sprites.
By further testing, I found out that the 4-byte chunks in every bank are switched places, so if you skip first 4 kilobytes and then put a CHR there, the sprites would be switched with the background tiles. So this helped for me to realize that the CPU addresses 13 and 12 were switched places. And it turns out I actually made that mistake while still designing the PCB. Yeah. After fixing that, I could run every UNROM image, but there was one issue: the constant graphical glitches. At first I thought maybe the culprit is the incorrect cap values, or perhaps that not all solder pores on the PCB are connected together. But no, the problem was my crappy drilling, because I tried to drill the holes for the static RAM from different sides of the board, and it led to the fact the RAM socket was all crooked and the chip could not be properly inserted. So the legs were wobbling all the time and the poor connectivity caused the glitches. My final decision was simply to remove the socket and just solder the RAM directly. It's not that I need to change it constantly. The final result isn't that pretty to look at, but it works, and that's what's important to me. I will definitely try to make more cartridges like that, since I still have plenty EEPROM and RAM chips left. I bet my next cartridge will look much better. Besides the cartridge looks, I want to improve the production cost, because it wasn't that cheap. Not counting the hours I spent working, broken drill bits, and upcoming electrical bill, this exact cartridge costed me about 21 euros to make. Yep, fancy EEPROM and even fancy RAM were the most expensive parts. Now with the Taiwanese no-name static RAM, the cost dropped to 17 euros, but there is still a place for an improvement. It would be interesting to try replacing the retro EEPROMs with some cheap 3-volt flash chips, also to replace the logic chips with something more common. It seems nobody really uses the OR gates or 4-bit counters. At the time I'm making this video, I ordered some fishy looking EEPROMs for €1 each. I'm curious if they would be any good. Of course, it would be even cheaper to order everything from China and probably even produce the PCB there, but I would rather not. So I don't know if anyone would need my amateurish KiCad files, but I will probably create a GitHub repository anyway.
since I will be improving the cartridge design from time to time. You will find the link in the description. So yeah, the video ended up being a bit long, so thanks for sticking with me till the end. If you want to learn about the UNROM mapper, you can check my previous video. And if you want to see my more detailed PCB etching process, you can watch this video. So that's about it. Thanks again for watching and see you in the next one. Bye!